So you've made the case that robots and houses have a lot in common. What are the main similarities there?
Well, robots and houses both share sensors, which are anything that records information and reports it. Actuators, so anything that can take an action. And what can make a house into a robot is putting a brain between them to help them make intelligent decisions. So a real simple example of that is the thermostat in your house. It can sense the temperature and it can adjust, turn your heater on and off. The part that makes it useful is that it can tell when to turn it on and off to keep the temperature right where you want it to be. That's the simplest example of a tiny, simple robot in your house.
Right. So the pieces are already kind of there.
Yeah.
What's the main difference between robots and houses there? Is it that one is adaptive and one is not?
Part of it, well, right now, yes, it's very rare to see a house that learns and adapts. And in fact, a lot of robots don't learn and adapt. They're programmed to do something very specific. We're used to thinking of things that look like complicated arms when we think of a robot, or say a vehicle that drives itself. Really though, what these things all have in common make them indistinguishable from a house. So the thing that makes them special and makes them useful is the ability to adapt to what's around them. Whether it's a robot or a house, lets it become what we think of as intelligent.
How can houses become adaptive? How do they get those brains? What's required?
So this is a tricky problem. This is a big problem. A lot of people are trying to solve it. You can take a very first pass approach at this by making a list of rules. So, for instance, like you might do with a small child, when you want to take that child and say, I want to keep the child safe, I want them to be happy, I want them to have an interesting life. So, don't run in the street, be sure and eat your vegetables, and here's a list of movies you can watch. The world is more complicated than any list of rules that we can come up with. There are always things that we don't foresee. So, luckily, children are wired for this. They take the rules, some they follow, some they don't. They actually learn a lot when they don't. And then they find themselves in situations that are completely unlike anything they've been prepared for. They've received no advice and no rules for how to handle it. And so they have to figure out, based on what they've experienced, what the best thing is to do. That's the missing ingredient in houses. We can tell a house, hey, we have a thermometer, I want the temperature to be this, and I want the security alarm to go off when the doors are locked in the middle of the night. There are always exceptions to those rules, and having a brain behind that can learn those exceptions the same way a child learns to navigate the world has the potential to make the house really a much more powerful assistant for us and save us time and money and natural resources and keep us safe.
It feels like houses at this point are very much a blunt instrument. Is that a fair characterization?
Yes, and in this case, houses are a specific example of a much wider phenomenon. We have a lot of things that have a lot of sensors. And as computers get more and more widespread and electronics get cheaper, those sensors get more plentiful. Our phones are loaded with them, our cars are loaded with them, infrastructure, roads, pipes, computer networks, everything's really heavily instrumented. There's a lot of information. Using it intelligently to get those systems to do the right thing is the same hard problem as getting a house to learn what it is we would like it to do. So it is the root of the excitement behind the Internet of Things. The promise that everything that has sensors and everything that has actuators can take actions can be somehow made intelligent by putting the right brain in the middle. And that's the focus of the work that I like to talk about.
Is there a particular part of the Internet of Things that you think holds the most promise, or maybe is closest to realizing what it could be?
That's a tough question. I think that when I think about what the Internet of Things is, what that means in my head is something that has sensors and has actuators. So basically, it's ready to be a robot. It just needs a brain. I think that cars are very close, and in fact, we see that they're going from the laboratory to production, getting very close to solving some of those problems. So maybe it's not even fair to say that they're close. Maybe they're already there. If I had to pick a second fun one, it would probably be manufacturing, because there are a lot of it's a carefully controlled environment. There are a lot of sensors in place, and it's something where there is enough money behind it to do something useful, and enough, because it is somewhat simpler than the wild world most of the time. It's easier to make headway there.
Sure. Last question for you. What people or projects are you following these days?
I don't have any individuals that I follow very closely. There are general research in this area. There's a lot of research areas that have the potential to contribute here. So what's known as deep learning is getting a lot of headlines. Deep reinforcement learning is the extension of that to specifically making decisions. So there's a handful of people and companies doing research in deep reinforcement learning that I like to follow. And then I've been a sucker for robots since I was a kid. So anything where you've got a machine moving around, that excites me, and that comes up on my news feed on a regular basis.
Great. Well, thank you for being with us.
Thank you for having me.